Okay, so what we're going to do today is to practice some skills in reproducible organization, documentation, automation, and dissemination. I'm going to touch on a few things that are specific to medical or biomedical research because that's the focus of this, and also touch on some things that go through the whole research workflow. There is a lot that I've put into this, and we are starting a little bit late, but I hope to be able to at least introduce all the things I intend to talk about. If there's anything in particular that you yourself are here to learn about and we get there and you want me to spend more time, raise your hand and let me know. Don't be shy, because the whole purpose of being in the same physical room as a group of people that are interested in learning about this is to be able to customize it to a certain extent to what brought you here. Does that make sense? So generally speaking, this is what we're going to do. We're going to do a very brief introduction into reproducibility, a little bit of definitions, but I'm not going to spend a lot of time on that because that's something that you can actually read quite a bit of on your own, and it's also quite discipline specific. So what I hope to spend most of our time here together doing is actually going through some exercises, getting our hands a little bit dirty with some of the tools you could use to help improve the reproducibility of your work, and also introduce some resources that I think are good places to start for trying these things out for yourself. So generally speaking, we're going to talk about registration or pre-registration of a study. We're going to talk about the importance of creating a complete and transparent study protocol and what might go into that. We're going to do a little bit of data collection together with our candy. It'll be fun. Don't eat your candy yet. And we're going to talk about reproducible organization, including creating a central repository for all of your research materials, separating data and code, saving results explicitly. If any of this is confusing, it's okay. We're going to talk about it. We're going to talk about documentation. What are some bare minimum types of documentation you can make? And then in addition to that, some resources for finding other richer documentation you might want to accompany your research as you share it. And then we're going to dive into some of the aspects of reproducibility that relate to the computational side. So what I mean by that is the ability for someone to take your data, rerun your methods, such as your code, with your data and get the same results. So that'll include a specific type of documentation to support computational reproducibility, how to include automation of your analyses to a certain extent to improve reproducibility, and then we'll finish off with talking about sharing your results, publishing a reproducible paper, and how you can disseminate your work more reproducibly. So that's a lot in 2 hours. So time will be my greatest barrier, I suppose, to overcome. But don't let that stop you from raising your hand and asking questions, because the slides are always there. If we have to skip over something, people can always refer back to it later in the slide. So for you who just came in, there's a few things up here for you if you want to grab 2 sticky notes, one of each color, and a handful of candy. And there's food there for you as well. Okay, first things first. What's that? I'd put your name and email there. Yeah, perfect. Okay, so we're going to do a quick icebreaker. Everybody stand up. You'll find out later why I'm going to do this. Okay, so what we're going to do is we're going to form a line. From over here is the person who has done some coding related to research most recently. Okay? Over here is the person that has never coded, doesn't know what code is, doesn't even understand what I'm talking about. It's all gibberish to them. You're over here. So what you have to do is talk to each other and find out, when was the last time you did a little bit of coding related to research? When was the last time that you did? A couple years ago over here. We have last night over here.
I have a team that does that.
You have a team that does it? I think that puts you over here.
No, but I've coded in the past.
Okay. So how far in the past? She's a few years ago. A couple years ago, you guys are over here. code? You don't know what it is?
I know what it is, but I've never coded.
Okay, great. This is great.
Okay. For homework.
For homework, that totally counts. What about you? Over here, great. Okay, so the reason we do this is partly to just get up and sort of like talk to each other and break that sort of barrier, but also because some of these exercises towards the end are computationally related, and it's important to be able to help each other out if someone is having a problem. So for those of you that might be new to some of the coding we might do, these people will help you. And for you guys, when you finish your exercise, if you finish it before someone else, take a look and see if there's someone around you that could use a little bit of help. Okay? Thank you. Okay.
Just yourself. I wasn't sure where to go.
So let's start with your thoughts. Raise your hand if you think that there is a reproducibility crisis in your field. So raise your hand if you think that there is a major crisis. Okay? Raise your hand if you think there's a slight crisis. All right. Raise your hand if you don't know. Yeah, that's good. That's fair. Raise your hand if you think there's no crisis. Somebody? Nobody? Sometimes happens. So that's pretty close to, the general researcher population. People are a little bit disagreed to the extent of what type of issue, like how we should be framing reproducibility. But across the board, people are concerned about it. But I actually like to frame this a little bit differently. Raise your hand if you have ever failed to reproduce or replicate someone else's work when you tried. Okay. That is pretty common. Raise your hand if you ever tried to reproduce your own work and failed. Okay. You never did. See, look to him. He already knows what he's doing.
Not in there.
So, the way I like to frame the sort of things we're going to cover today is that any of these things that you might do to, quote, improve the reproducibility of your work will benefit your future self most. That is the collaborator you're most likely to work with, is yourself a few years down the line. And that's because a lot of these best practices are just a matter of tracing your workflow, documenting your workflow, organizing things in a way that are human understandable. And we all know that our memories are, not as good as we'd like them to be. And it's hard to remember what was the version of the data you used to get that figure and things like that. So choose those things that we cover today or that people do in your field that are going to help you first, are going to improve your reuse of your own work. And then with every time you start a new project, you can bring in a new thing that will help you. And in the end, you are also making your work more reproducible. I don't think that framing things as a crisis is a very good way to motivate people to actually try out, new methods and new tools in their research. But there are lots of new technologies and new approaches that are available to us now that will benefit us first, and those are the good ones to start with. So I like to think about this new insight into the reliability of published research findings as an opportunity. So this is, something that people have started to study over the years. We now have more insight into some of the systemic issues that we're facing as researchers that might cause us to have, bias in our findings or missing information in our published papers and things like this. Now that we know that, we can take that knowledge and we can take our new technology and we have an opportunity to accelerate how quickly we advance science and advance research. So if we frame it as an opportunity, it's a good way to not, shut down if we feel like we can't do everything at once, and also to frame it as, it's not a matter of pointing and shaming people that aren't following these practices, but trying to learn from the past and always do a little bit better with each new project that we do. So this is where we have to start talking about, what do I even mean when I say reproducibility? So some of you probably have a sense already, or you probably wouldn't be here. I myself have pet definitions that I like to use, but they're not by no means the only definitions, and you guys might have come in with different set of definitions. The definitions I like to use are Victoria Stoughton's from 2014. She has since revised them, but let's ignore that. Because what we need to keep in mind is that there are as many definitions of reproducibility and replicability as there are papers defining them. The important thing is to find the definition that is appropriate for your discipline and your methods, and to communicate that definition with your peers as you talk about these things and come up with what you might do in your own groups to try and tackle the improving of reproducibility in your methods. So you can see here, this is a preprint from Lorena Barba, who she tried to sort of catalog all the definitions up till 2018 of reproducibility. And you can see there's no shortage of different definitions. The Victoria Stoughton ones are useful because she breaks it down into 3 types of reproducibility. So she talks about empirical reproducibility, which is sometimes called replication, which is when you're actually redoing someone's entire study to see if you can get the same results. Statistical reproducibility has to do with those issues in reproducibility related to your statistical methods and choices. And computational reproducibility is the baseline of reproducibility. What it is the ability to take someone's data and code or data and methods, whatever materials that they included in their published paper, and to rerun them and get the same numbers, figures, tables in the published paper. So you can see it's a subset of reproducibility. It's a more focused, just replicating the numbers and figures in the paper without rerunning the entire experiment. But the thing that makes it important, you can view it as a prerequisite for the other types. In order to understand the statistical methods, whether they're appropriate, whether they're reproducible, you need to have a sense of the analyses that they did in a pretty detailed way. And in order to rerun an experiment the same way that someone else did, you need to have a pretty detailed understanding of those methods. So you'll find that I spent quite a bit of time on computational reproducibility today, and that's because it is that sort of foundation upon which the other types of reproducibility are built. And it's also because one of the platforms I'm going to show you and that you're going to work with is CodeOcean, which is the company that I work for, and they focus on computational reproducibility. Any questions about definitions? Yeah.
Can you clarify the difference between computational and statistical then?
Yes. So computational reproducibility often will include the type of information that you might need in order to assess statistical reproducibility. So for example, statistical reproducibility could involve, say, let me think. So maybe you have low power or something, right? So raise your hand if you know what I mean when I say power. So essentially, how many observations, how many patients you have or whatever. You have low power, that will affect, the chance that you might have a false positive in your results, right? So in order to know that, you're going to need to see what tests you ran, whether or not you were doing a 2-tailed t-test or a 1-tailed t-test. These sorts of things will help you assess whether or not the statistics were appropriate, whether you had enough power to run the test to find the difference, clinically significant or biologically significant difference that you're testing for. So in order to evaluate that statistical reproducibility, you're going to want to have the methods with enough detail to rerun those statistics. And in most cases, people are using software to do that nowadays. So that will include if you're using some sort of coding, such as R or Python or MATLAB or Stata or SAS or whatever you're using, you would want that code. So the computational reproducibility is the rerunning of the code and the data to recreate those numbers. But assessing statistical reproducibility will also have a level of statistical expertise. Was that test appropriate? Is there enough sample size to make that a reliable, finding? Is that help? Okay. Anybody else? Okay, I've already talked more than I want to. In conclusion, not the end of the workshop, just the end of me talking, hopefully. I ran these for a few years where I gave people a pile of things to do and saw them again a year later, and they had not actually, taken any of these things and incorporated them into their workflow, even though they had enjoyed the workshop and everything like that. And I think part of that is because I used to frame these as, here's the best practices, gold standards, this is what you should aim for. I think in reality, what we should be doing is every time we start a new project, think of one thing that you can add to make it a little bit more reproducible and add that into your workflow. With every step that we take over time, we're going to push our research down the line, down the spectrum of reproducibility. It's not an all or nothing situation. So if you leave here and you just decide from now on you're going to create a nice protocol and share it with everybody, then that makes your research more reproducible, and that is a positive outcome out of something like this. That's a discrete moment of time we will spend together. So thinking of it as a spectrum, I think, is very helpful. And don't become too overwhelmed by the many things that we're going to talk about today. Find which things are most useful to you and just start with those on your next project. Okay, so what do you do? We're kind of living in the golden age of reproducibility guidance. So I like to sort of share my favorite because it's easy to get overwhelmed by how many people will tell you what to do. But it is useful to find examples of guidance that are specific to your field and methods once you start to try and dive down into this a little bit more. But to begin with, this resource, The Practice of Reproducible Research, is great. It's a free Get book. And the thing that's great about it is that it includes case studies. So it's one thing to look at a list of best practices. It's another thing to figure out how do you actually implement that into a real lab, a real research group. That is not always straightforward. So having the case studies helps you to see real-life examples of people trying to deal with the messy world of applying best practices to humans who are messy. But one thing you'll find as you go through all these different guidance documents is the same themes will come up over and over again. So organization, documentation, automation, and dissemination. These will look different from one discipline to another, from one method to another, but those are the core facets of reproducibility that apply across disciplines. For some people, organization might be much more important. If it's a massive, complex, multi-year project where your main struggle will be keeping on top of all your materials and your versions. For other people, it's going to be more important to just share everything. So what these will actually look like to you will vary from what they might look like to someone doing a completely different study. But the things we're going to go through today, I've selected as things that apply across most disciplines and also will do no harm. Like, it won't be bad practice to do it. So for example, for data documentation, different fields have different ways of providing metadata to accompany their data sets. So metadata is just information about your data. And we're going to talk about, for example, creating a data dictionary. Not every field creates data dictionaries, but if you're doing this for the first time and you create a data dictionary, it's not going to hurt anything, and it will improve the transparency and reproducibility of your work. Okay, so let's take a quick breather. Any questions so far? Yeah, okay, so I have talked a lot, which I know is a problem I have. Just to sort of break that up a little bit before we get into some of the exercises and demos, raise your hand if there's something specific, a question that you specifically are hoping that we're going to answer today. Someone want to raise their hand, volunteer? That? Yeah?
I was wondering, sort of a historical question. journal endocrinology used to require 3 replicate experiments.
Oh, yeah, within the same lab.
As opposed to 1 experiment with 3 biological replicates within it. What's the current standard for reproducibility in the paper? To have to basically do the experiment at least 2, not 3 times, or not?
I mean, it's all over the board, right? It really depends on the discipline. Like in some areas, you couldn't possibly put in multiple replications of the same experiment.
But it seems like, to me, that's my experience, kind of along with the 2, that does contribute to lack of reproducibility. The standards for, you actually haven't reproduced your experiment when you publish it.
Yep.
So it's not reproducible when you then go back to it.
Right. You got what you got at one time. You might not even be able to get it again yourself before you
Is that
publish.
your experience, Bill?
Journals have just recently, in the last 5 years, started requiring you to specify your N and your replication.
Yeah.
And that's trying to get at this problem of reproducibility. You know, when your N is 9, was that 3 experiments of 3 mice each, or was that 1 experiment where all 9 of them through at once? You know, and they want to know that now.
Yeah.
Statistically, power-wise, it doesn't matter, but from a reproducibility point of view, it does.
Yeah, I think at the baseline of all of this is that if you have enough information to understand how many times this has been done, like if people are registering every time that they run a major study, so that if they've run it 10 times and they're publishing 1 paper out of that and they got significant results only 1 time out of those 10 times, that gives you a little bit more transparency and a little bit more of a chance to take that finding with a grain of salt. I think publishers, as far as the role of publishers is concerned, I think there's a push for having greater standards and what is asked of authors. We're going to talk a little bit about reporting guidelines, and that kind of gets at that. But it's going to have to be something that is not just with the journals. There needs to be, like, journals have, on the one hand, they'll say, you have to provide all this information in order to publish, but on the other hand, who is it that's enforcing that? It's going to be a bunch of volunteer reviewers who are already strapped for a lot of time, and the evidence has shown is that even though there are these improved policies, with some journals, there isn't yet any teeth attached to those. There's not really rejections hinged on that very commonly. So I think it's a challenging thing to address, right? It needs to be maybe more discipline-specific norms, different community standards coming out saying maybe you can get that published, but we as a community want more than that. So starting with organization. Yeah.
So one of the comments, one of the challenges we have in our field is this concept of semantic interoperability.
Okay.
And how metadata is managed, I think is a big part of that, and a lot of people don't manage that properly.
No.
So when you have these terms, you plug them in and you run analyses and you make assumptions, and you're not supposed to make assumptions. That's where some of the problems lie. So
Right.
I mean, you've already partially covered, talking about the data showing how important they are. There's the structural and the descriptive types of them, which is, again, not always done, even in biomedical practice.
Mm-hmm. Yeah, and I think that also speaks to a gap that we'll find between, theoretical reproducibility and active reuse, or ease of reproducibility, the ability to actually take someone's work, to rerun it without putting in too much labor, without having to communicate with them and ask them for follow-up if there's missing metadata or if it's not interoperable or things like that. I think a lot of the stuff that we're covering here today is going to be much more basic than that, because the metadata stuff comes into a lot of discipline-specific, best practices. Some data repositories will have a certain standard, other disciplines will have a different standard.
Are you referring to reproducing from a code repository, so someone uploads their data, you download the data, you run the experiment, or you take the computational methods and apply your own data in there and try to come up with similar results for your institution versus another institution. Which one are you referring to?
So I would say the baseline of it would be that ability to just recreate using, say, a code repository or a type of repository with all the materials in it, plus the publication, being able to recreate.
Using the same data.
Using the same data. That's the baseline. With the idea that you should be able to also have enough information from the article to also recreate the study. But that is a more advanced.
Isn't that why you were trying to break down the different types of reproducibility? I mean, in some ways what you're talking about is, are you doing a replication versus statistical versus the computational?
Yeah.
I think if you're just recreating somebody's experiments using that's the statistical approach, right? But if you are going in and bringing in your own data, trying to reproduce what's happening.
And you're right. That's exactly right.
Yeah, the computational reproducibility is really limited to your publication. The things that the person's shared, you're using the same data, the same code. You're just going to see if you can get the same numbers and figures. And then with the idea that the gold standard is going to be some type of replication, full replication of a study, and even beyond that, some sort of conceptual reproducibility, which is like, okay, you can rerun the study and get the same results. Are they robust to a new population? Are they robust to different approaches to this question? Which is the even farther beyond that goal. So it's all built upon how generalizable is that study? How much information do you have access to so that you're following the original study as closely as possible, and then eventually being able to depart from it. Because that's what research eventually
I think
wants
that's
to
where
do.
in our area, I think that's where the bigger problem is.
Yeah.
The conceptual model of being able to apply it to one institution to another and compare. The outcomes, population base, should be similar.
Right.
You take stroke patients from the East Coast, stroke patients from the West Coast, and you run an analysis on it. Whatever you're looking for should be relatively close because the population is not different.
Yeah.
If you have numbers large enough.
Yeah.
I think that's where a lot of the issues are in our area.
Yeah. And it's always interesting to talk about, every discipline has their core barriers, that need to be overcome, which is why the disciplines, specific conversations are so important to advance these things, because, when you're talking about patients, you're going to care about different things. When you're talking about atoms, you're going to care about different things. And you're going to be using different methods. So there's always a struggle to talk about these things at the higher level. They're always, things get so broad they become useless. And then you start to dive down to the specifics and it's too specific and someone's left out. So I'll try and strike a balance in there. So in terms of reproducible organization, if you are in clinical studies, this is probably not new to you. But for other disciplines, this is a new idea. The idea of a registration, or sometimes called a pre-registration of a study before you collect your data. What it is essentially just a read-only public record of the basic information of your study. It's not meant to, chain you too tightly to exactly what you envisioned your study would be. But one of the things it will allow you to do is to create a public record of this study, so people can have a sense of who else is doing this type of research, and when you publish something, they can have a sense of, is this the first time you've done this, is it the 50th time you've done it? So you have a bit of an insight into, how many studies are going on at any particular time. So raise your hand if you do clinical research of some sort. So if you're doing clinical research, you're already legally required in most cases to do something like this. Clinicaltrials.gov is the commonly used registry. Oh no. Yeah, perfect. Easily solved. So this is a way that other researchers and patients and the public in general can have a sense of what research is going on, and hopefully if they've also followed up with the results, you can actually easily get a sense of not only what trials are being run, but what the basic results of them are. So this helps improve the transparency, and it also helps combat what we call publication bias. So publication bias is a bias in publishing across disciplines where what's called a significant finding or a novel finding is more likely to be published than a, quote, inconclusive or negative finding. And the result of this is that you might read a published paper and you think that this new discovery has been made, but in fact someone ran this particular study 50 times. They happened upon a significant result one time, published it, and that biases that effect in the literature towards being a more positive result than actually exists in reality. When you take a registry into that world and require registration, then it does give people that insight into how much research is going on, so they can have a better assessment of how reproducible a particular finding might be, or how likely it might have been to have been a false positive just because they just did the study so many times. Another thing to think about when you're thinking about a registration of your study in advance is to think about your analysis plan. This is something that people will often leave out of a pre-registration, but because there are so many choices that people can make in their analysis, and our tendency as humans to decide on those choices that support our own worldview or pet hypothesis, there is a risk with every one of those choices of creating a false positive. So if you think in advance before looking at your data about how you're going to analyze it and document that somewhere, that helps to give yourself a little bit of objectivity as you approach your analysis and helps to counter that risk of a false positive. It's none of this is like, a magic bullet, but these sorts of things can really help to improve transparency and really help to separate out what are could be an exploratory analysis that you're just kind of like making some choices to just kind of dive into the data and see what's going on, or a confirmatory analysis where you're actually like testing up a hypothesis and you might want to create a pass some sort of threshold of discoverability, such as a p-value. So raise your hand if you know what a p-value is. Okay, so most of you use p-values in your research. Raise your hand if you're not using p-values or some sort of threshold of significance. Okay, everybody here is. So that makes it more straightforward. Yeah, so for people that are using hypothesis testing research and they're aiming for a significant p-value, thinking about your analysis in advance of collecting your data is a great step towards improved reproducibility. So you'll see here some tools you can use to create a pre-registration. If you're using clinical research, you would use clinicaltrials.gov or whatever appropriate registry is for you. This is what I just said but didn't have it on the slide. So if you want to read this later, you pre-register your study before you begin recruitment or before you collect your data. It can distinguish between those decisions you made about your study before your data was collected or looked at and those that you made after you've collected your data, because that will inform, how you might approach your study design or your analysis. So like I said, it does counter reporting biases such as selective reporting or outcome reporting bias. This just means that by pre-registering your study, you will decide what your outcomes are. You will decide which outcome is your primary outcome, for example, which is the outcome that your sample size and power will be calculated on. When you combine a public registration with some sort of mandate, such as like required registration across a field, you can also counter publication bias. So when you want to add to your registration an analysis plan, you want to define exactly what your hypothesis is, And what are your analyses that will confirm or deny that hypothesis? What's your threshold for accepting it versus rejecting it? What are your primary outcomes? What are your secondary outcomes? What are some exploratory analyses you might plan on doing? How will you deal with missing data? How will you deal with outliers? How will you deal with doing multiple tests on the same data, which can increase your chances of having a false positive? So there's lots of things that you want to address, and there's some guidance, and I'll show you some in a minute to help sort of decide what to include in this. But these sorts of things are examples of things that are good for science in general, but they're also good for yourself. It helps to improve the completeness of your study plan before you start, and many times will help improve your study as well. So when we say that registering an analysis plan can reduce what we call researchers' degrees of freedom, this is what we mean. A researcher degree of freedom are all those decisions a researcher makes in their data analysis after they've looked at their data. So you can decide, for example, which variables to keep, which ones to drop, what variables to control for, and which ones to not control for, like whether you're going to keep all your outliers, whether you're going to, deal with your missing data this way versus that way. Every time you make those decisions after you've looked at your data, you're increasing your chances of a false positive, just because of the way that our brains naturally work. It's not fraudulent. It's not malicious. It's just a normal way that a human brain will, try and make their results feel right. The approach that will feel right to a researcher will be the approach that most aligns with their worldview, which in most cases is the answer that supports their hypothesis. And because that is the way human brains work, anytime you can take, these decisions, and sort of think of them before you see your data, the more likely you are to be able to rein in some of those biases. Does that make sense? So again, I'm talking too much. I'm just very sorry about that. So just really quickly, one example, if you are not doing a clinical trial and you do want to try out a pre-registration for the first time, the Open Science Framework has places you can do this for free. And one of the nice things about the OSF, other than the fact that it's free and open source, is that they have a variety of templates to make your first pre-registration very straightforward. So here is an example of what a pre-registration looks like. It's a read-only public document. So you see this is read-only. People can share a link or a DOI, which is a permanent identifier linking to the registration. You can put it in, for example, a published paper so people can see how your study started and understand whether or not your p-values are as robust as you claim that they are. So you'll see here the sort of things that people would include. They would list their research questions, their hypotheses. They'd talk about their sampling plan, their different variables. What's your stopping rule, right? Thinking about that in advance. Like it'll lower your chance that you're going to stop it just when you feel good about the answer that you find. So study type, how do you randomize? How are you going to analyze your data? All of these things are important things to think about in your study anyways, and when you document them and share them publicly like this, then you're also making your research more reproducible. Okay.
April, I'll give a shout out. We have a institutional portal into the OSF, so if you go to osf.uc.edu,
Yeah.
and if you click on sign in with your institution, choose Cincinnati, it actually pops up our window for our 6+2, so you can set up in the Open Science Framework really easily.
Can you give me that address? OSF?
osf.uc.edu.
Uh,
嗯
OSF.uc.edu. Excellent.
There it is.
So you can actually see,
And we don't have any registration.
oh, there is a registration.
Oh, that one.
Somebody here at your institution has already started doing this. So that's just one example of how you can create a pre-registration. Because of time, I won't demo a registration right now, but if anyone's interested, I can show you later. Okay, so everyone has 2 sticky notes, correct? All right, so let's put the yellow sticky note up on your laptop. If you brought a laptop with you, get that out now. So essentially what we're going to do is use these to signal where we're at in the exercises as we go through them, so I can easily see if people are having a problem. And also, if you finish and switch your sticky note to white, you can look around and see if someone around you might need a little bit of help. Okay, so one of the most important parts of reproducibility, as we talked about before, is reproducible reporting. And this starts from the beginning with the creation of a protocol. So there are tools out there to help you to create a complete and transparent protocol. And that includes what we call reporting guidelines. So a reporting guideline is an evidence-based document. It's created through consensus. They're study design specific. So you find the reporting guideline that is appropriate for the type of study you're doing, and you can be confident that that was created by a group of experts, people that conduct research, people that use research, for example, for meta-analysis or systematic review, policymakers, anyone that might have an interest in a publication or a protocol. And they've come up with the minimum set of items to address in your protocol that will create a complete and transparent protocol. So I highly recommend you take a look at the Equator Network. It's here. It's a database of reporting guidelines, and you can search in here based on what kind of study you're doing. The most commonly used reporting guideline is Consort, and this is for randomized controlled trials. So they update these every few years or so based on the feedback. And you can, here, I'll show an example of what one looks like. See here, it's a checklist. So not only is it helpful improving the transparency and completeness of what you're writing, but it can actually improve your document. So this is for the final report. Consort is. But the one for creating a protocol for randomized controlled trials is called Spirit. And that will include all of the things that are important for someone to assess your study. So it'll include information about important study design, methods, the intervention, all these sorts of things. Statistical methods, what information you need to provide in your protocol for your statistical methods. So it can make it a lot easier to create a good protocol. So once you've created a detailed protocol, you want to ensure that you track changes to that protocol over time. Again, if you're in the clinical world, you probably are already doing this, but this is something that other disciplines can benefit from. So you can actually see the evolution of your study over time from your first documented protocol to the one at publication. You can track how that's changed, and that gives people an insight into the evolution of your study. There's lots of tools that can help you to create a good protocol and to share a good protocol. Bioprotocol is a journal where they'll actually do peer review of your protocol, so that can really improve the quality of it. Penelope is a tool. It's free for researchers where you can upload your protocol into their online tool, and it will actually assess it for compliance with these reporting guidelines that I said before. So that's a very useful tool. It will be like, oh, you didn't mention how many people you're going to recruit. Oh, you didn't mention, did you do a one-tailed or a two-tailed? So these tools can really help you. The one that I'm going to show you right now is protocols.io. So this is an example of Spirit. This is if you're doing a clinical trial, you follow this guideline here. Protocols.io. I thought I put a link in there. Oh well, I have it over here. Is an online repository. It's free to use, and it focuses on protocols. Not just clinical or biomedical, but any discipline. And what you can actually do here is, here we go. You can see here, you can create a step-by-step protocol for whatever your study is. And you can create multiple versions of it. You can add collaborators. It's got a lot of bells and whistles. I'll show you how it's very easy to use. You just have like a section name, and then you can edit really easily. You can put in timers for if you're doing the type of work where you would say, need some solution to, sit for a certain amount of time. You can put that in there so that people will be able to easily replicate your experiment again. So I'll show you what that looks like. Once you've created a protocol, you can then use it, or anyone else can use it by following along by clicking, what did I click? Something like do experiment or something? Start experiment?
Maybe, yeah.
Something like that? Okay. So this is an example of a way of using a tool to easily not only improve reproducibility, but actually make your life easier. Like I said, this one's free, so that's good. There's other examples of things out there. There's LabStep is a new one. Some electronic lab notebooks will have this type of feature as well. But for right now, we're going to quickly go through this data collection exercise together using this protocols.io, and then we'll take a break because I know I've been talking your ear off for an hour. So everybody should have some candy. Does anyone not have candy? You don't have candy? Okay, let's give you some candy. There you go. So the first thing we're going to do is take a look at our candy and think about how happy we are with our candy selection. Okay? So see here, we're doing step 1, and then we're doing step 2. We're going to rank it from 1 to 10. Then in this Google form, oh yes, you guys don't have this. In this Google form, sorry, this is what happens for making changes and not actually updating the slides. So on this slide, you'll see the link to the Google form here. So for those that are following along in the slide deck, this is why that's important. Okay. So we're going to record in that form your name, your candy happiness rating, and select trade number 0. So you'll see here, I'm going through this. I can actually click this timer, and the timer will start. And when I finish that step, I'll hit pause. And this will actually create a record of this experiment. So there's a protocol. Then I start an experiment. I go through the protocol. I can deviate from the protocol and record those changes. I can deviate from how long a particular step was done and record that. And these nitty-gritty things in some disciplines make a big difference about whether something's reproducible or not. The person who created protocols.io spent the first, I think, 1.5 or 2 years of his PhD trying to replicate someone else's lab experiment. And it turned out it just had to do with the timing of one step, which is part of why he has the timer and the tool that he built. But for certain types of work, this sort of thing is quite important. And it makes it really easy to track those things when you have a tool like this. So anyone having a hard time either getting to the form, putting that information in? Okay.
What's the URL for this site?
Yep. Oh, for protocols.io?
Is it on the slide deck?
Yes.
You said to click Google Forms. Here.
It is slide number 25. You want to click on that Google form here.
Yeah. Click on that.
All right.
And then you will
Log
put
into the website and then visit the thing called
April, trade number 0. I am reasonably happy with my candy selection.
Oh, you did it after that.
What's that?
Should you read them after that?
Don't eat them yet. Okay, so if you've done that successfully, switch to a white sticky. If you're still having trouble, leave your yellow sticky up and I will see you. You still getting that? Oh, you gotta get Wi-Fi. So that's a false alarm, right?
I'm assuming 10 is high and 1 is
Where's it coming from?
Oh, you don't have, okay. Do you want to?
Oh, that's our timer, isn't it? Yeah, that's the timer. Oh, I was like, what is that noise?
Oh, it's my timer.
I know.
It is the first Wednesday of the month, isn't it? But we've already had our.
Yeah,
Mr. Candy.
my LabStep driver told me about that.
I just don't want to eat it. That's
Okay, so I still see some yellow stickies up. Sometimes all I need to do is say that and then they disappear. How's it going? You good? Okay. Okay, so the rest is very similar. Find one trading partner to trade with, just one, okay? And so put up your yellow sticky again. Okay, and now trade with that one person, and then again put in.
We're switching all of our candy, right?
Yeah, you can trade all your candy. Yeah, yeah. Just with one person.
Okay. Trade number. We're trading now.
We're
We're on trade number 1, right?
And this is trade number 1. Exactly.
No, I think the same thing, so, yeah, I'll copy
So, what's that?
They don't really.
No, just for your overall candy selection.
Oh, okay.
Yeah. How happy are you with your family of candy?
Is this on, sorry, which slide? Was it 25?
It was slide 25. Yeah, sorry about that. I moved the protocol into protocols.io and then I realized I didn't share the protocol with you, so there's that.
I don't like calculations.
Okay, so this is trade number 1. And you pick how happy you are with your whole selection of candy. So once you've done that, switch to a white sticky so that I know that you're on board. Cool. How are we doing? You still
I'm just, like, I finished that, but I just trying to get
to the form? Are you on the slide deck?
I am now, but I'm just trying to get to the right slide.
Okay, it's slide 25 and it's filled with text, like this. Okay, so I think you guys can predict what the last thing we're going to do is. Skip.
We're putting in just random names.
What's that?
Where's this participant name?
Yeah, you can put in your name, or as long as it's the same name every time.
Oh.
It's not the end of the world.
We're
We're not going to publish this particular
Okay.
experiment. It's just so we have some data to work with as we
Not
go
a
through this
metadata
stuff.
issue there.
Yeah, exactly. Okay. Ah! Sorry, guys. Pause. How are you doing?
Getting closer, yeah.
Getting closer?
You can keep, yeah.
Okay, I'll get going, but I'll make sure you're not left behind, okay? Okay, so now everybody, sorry, I should play this. Everybody trade with everyone else. We're going to do this for like 3 minutes. Carry your candy around. See if you can improve your selection of candy. And again,
Oh, good.
when you're
I'll
done,
give you 2 of those.
put up your weights.
I do. But I like quick, so we'll take that.
Okay.
Hi.
You're not even like.
I don't know much for drink.
Can I try this?
I don't mind.
Thanks.
Yeah. Need any more candy?
And,
Yeah, what do you want?
yeah.
I'll just give you that. You need some more candy.
Not much first one.
$10 in this bag.
Was on the
Is
table.
that- No,
I
drop
just
it.
figured it out, which is why
Well
she
done.
does.
I can go right over here. You know.
I did have a one.
Our response is going into this main system.
Oh, it's going into a Google.
Okay.
No, it's just going into a Google.
Okay, but
Yes, we did already.
your trash. Oh, it's just going to.
It's just a random Google form.
I didn't know if you're.
This isn't one.
So it's no real time demonstration of what we're doing.
Yeah, you have one.
I'm actually.
So we're using this to follow the protocol to collect the data. But the data is only connected in the sense that there's a link to the Google form, but it's not, the data itself isn't going into protocol.io.
No, I understand.
Oh, okay.
Normally distributed.
No, I have other fellows.
You're assuming that
All right.
the very population is.
So add your final happiness level, measure it as trade number 2, and then once you've done that, take a 5-minute break because you need it.
Eat your candy.
And eat your candy. Yeah, so you've got one final Google form thing to fill out. Okay. So at 2:10, we'll go through the computational reproducibility side of things. Now that we've got some data, we'll take some code, and we'll talk about how to make your research computationally reproducible. And then I'll turn this on. Has everybody filled out the form if they wanted to? Anyone?
The third one.
The third one?
Yeah, right.
Okay.
When is that due?
Hi.
Can I say kind of get like a template for Markdown or how articles would ask for the best practices of code
There probably is examples of that? Like you mean like a,
Variable performance standard.
Yeah.
Is there any standard?
so do you mean that is there standards for how to create a Jupyter?
No. For your code to be readable
Yeah.
and easier to read. Do they-
Like human readable.
Yeah.
Yeah.
Are there any known standards for that?
I think that there are good examples. I don't think that people have really gotten to the point of standards yet. But there are a lot of good examples of,
Work on good habits.
I can show
It's like
you.
a technical task. But that sort of explains
Good
to me,
example.
a couple of times. We actually
On writing reproducible and interactive papers. This is a really good guide. So they've created a notebook that actually takes you through how to create a good notebook, essentially. Yeah, for some reason it's taking a long time too, but that happens. Gotta do one thing before this. Yeah, sorry, but I will talk about this a little bit.
Okay. Thank you.
No problem. Okay. So hopefully everyone had a chance to have some coffee, maybe have a snack or something. So the next step in reproducible organization is to create one repository or one directory that holds all of your research materials in one place. The next thing to think about is how to organize that repository in a way that is useful in allowing another person to understand what's in the repository, so informative naming of folders, and also organizing like things together. What that actually looks like from one person's workflow to another could vary. Generally speaking, for most people, the separation of data and code is an important part of it. So when you have a data subdirectory and a code subdirectory in your repository together, it gives someone who comes to that repository for the first time a little bit of help understanding, what are these different materials, how might they relate to one another. Another thing to think about is to have a results folder in your repository where your results, such as your tables, your figures, things like that, are saved to explicitly as a result of your data and your code running together. So if you're not running code, like you're not coding, but you're using some software program, the idea is still the same. You want to make sure that you are, your results are always a function of your data with your methods. As long as you get in the practice of trying to keep that sort of pipeline connected, you can always know that that most recent version of your code with that most recent version of your data is the thing that created that figure. Because that's where a lot of people that come back to their repository a year or two down the line might find that they don't remember, for example, where that figure came from, what created that figure. So having a results subdirectory that you save to explicitly can help to counter that. Tools for organization, we already talked about the Open Science Framework. GitHub is another free tool that researchers can use to create a repository for their materials. As long as it's public, it's free. Electronic lab notebooks, if your discipline has some of these tools, they can help to organize your research and create some sort of documentation alongside it to keep everything together. And then CodeOcean also is another place to keep these things organized. There's a great resource if you're trying to decide whether or not you should use a lab notebook. Harvard put together this features matrix that makes it a lot easier to compare a growing number of tools that are designed for lab management or research group management. I won't go through those, but it's a good resource to start with if you're trying to make that decision. So I had a question during the break about litter programming or Jupyter notebooks. So Jupyter notebooks are simply a way of knitting together the narrative of your research with the actual analysis. So essentially you have a narrative code such as Markdown that's just text alongside in the same document your actual analysis code. So it creates a narrative, a human readable way of understanding exactly what you did step by step from start to finish. So it's considered to be a very useful tool for reproducibility. Also one we're not going to have time to dive into here today. I will talk about it in tomorrow's workshop. So if some of you are deciding whether you're going to do that, that's one of the things we'll talk about more specifically. But the reason why I need to bring it up now is because some of these things we're going to talk about in terms of computational reproducibility best practices relate specifically to a study that was done in order to assess the computational reproducibility of the published literature recently. So this group decided they were going to take these well-documented analyses that are Jupyter notebooks that are published in support of a published article and try and rerun them themselves. And they thought it was going to be as simple as downloading that code, that document, and rerunning it on their own computer. But they said it was hopelessly naive. So they tried 107 papers. At the end of this, it was an informal study. It was just a group of people trying it out. They actually only reproduced one out of those 107. Doesn't mean that the other ones weren't possible to reproduce with some effort. They just eventually gave up after they tried with over 30. They decided that the real lesson was that more needed to be done to improve computational reproducibility of published literature. So that is the lesson that we have learned, and that we will hopefully not be as naive as they will, and publish more reproducible papers. So what they found in their study was that the files, the data, and the dependencies needed to reproduce the analysis were often missing. And so what we can do is to organize for reproducibility. So we talked about one of the things that we need to do, which is to create one repository to hold all of the materials together. It's also important to archive the exact versions of the data used to support a published paper somewhere. So you have a repository, but you also want to, when you create a publication or share something, to know exactly what version of everything that supported that paper is, and to archive that somewhere so someone else can find it. One of the other things that they recommend is to bundle all of the dependencies together. Dependencies are just anything that your study relies on, any materials, any data, any what are called packages if you're using code, and to have them in your repository rather than just tell people to go and find them themselves, because they might not find the right version, or they might not have access to the same things that you do. So whenever possible, have everything that you need together in one place. And then you take that repository that has all your research materials in it, and you link that to your paper, as opposed to just a particular file. Does that make sense? Okay. Okay, so our first exercise. It took a while to get here. All right, so we're going to create one repository that holds all of our related research files together. So I did mention GitHub, right? So here is an example of a repository on GitHub called Candy Trade. here I am going to upload into this repository. See here, I've got all these materials in here together. I'm going to upload the data file that we just all created together. Assuming I can easily find it. Data, yeah, I was hoping it would be at the top. There we go. So what you do with GitHub is it's a place where you can not only store all your materials together, but it also has, it's a popular place for using Git, which is a type of version control. A version control just is a way of tracking the changes of your documents in one place in a way that allows you to, for example, roll back to previous versions to see who made what changes and who made them when. So how you do that is by committing changes to your file. So you see here it says commit. I'm making a commit by uploading my file. So now you see this is your data. Ta-da! Cool, cool. Okay, so we're going to go in a repository that holds all the related research files together. So we've got most of this stuff in here. We've got our data. We've got some code here. I'm not going to ask you guys to do any analysis coding here. So I've made some already that analyzes that data. So this is a nice little start to a repository that you might create for your own research. But remember with protocols.io, we did this experiment together. One of the things you can do is save an experiment that you ran, and then Wi-Fi is always everywhere we go. It's always an issue. And then download it as a PDF, and then you can put that into your repository. So it's another documentation of your methods. People can see exactly what you did. You did the experiment on this date at this time. You did 10 steps. How long did you do for each step? And they can see that you didn't skip any steps. So let's do that and put it into our repository. There's a little bit of a documentation of how we ran that experiment. Okay. So we've created a repository that holds all of our research files together. Now we're going to take that and we're going to put it into a repository where we're going to separate our code from our data. So everyone put up your yellow sticky. Okay, so we're going to take this repository, we're going to bring it into CodeOcean, and we're going to make it computationally reproducible so that it has currently, you can go to the GitHub repository and you can see all this information, and that's a great start towards reproducibility if you share that. And if you do only that, you're still ahead of the game and you've pushed yourself down that spectrum of reproducibility to make it easier for someone else to understand what you did. But the next step is actually to take this repository and take it from theoretically reproducible to actively reusable and reproducible. So someone else can come in and get started with reusing your research right away by just clicking the button. So the first thing that we're going to do is create a CodeOcean account. So just so you know, if you want to just delete this account at the end, please do. You can also put on the back of this that you don't ever want to receive news from us, and I will ensure that you are not only removed, your account's removed, but you're also removed from everything. Because we want to go through this as sort of going through the best practices for computational reproducibility, but all of these best practices we're going to cover are platform agnostic. So if you choose to use a different platform than CodeOcean, you can use all of these best practices for those different platforms. Okay? So the first thing we're going to do is create an account, put your yellow sticky up, and once you've created a CodeOcean account and verified it with your email address and you're able to get in and sign in, then put up your white sticky. How's it going?
Apparently doesn't support Internet Explorer.
Oh, it does. GitHub doesn't. Oh, I'm surprised by that.
I was
We-
doing CodeOcean there. Are we doing CodeOcean?
CodeOcean now, yeah.
Oh, CodeOcean.
Yeah.
But it wasn't working for me either. I'm gonna try it.
So actually, that's a good point. CodeOcean doesn't support Edge. There's no Edge, the browser
Yeah, Edge stinks anyway.
Yeah, that's how I feel too. I feel like everyone should have the freedom to use the
The only
browser.
browser on my Windows machine crashes.
Mm-hmm.
It's a Microsoft product.
Yeah. Do you use Chrome then, or Firefox, or what?
Huh?
What do you use instead?
Yeah, Firefox.
Yeah.
It looks like Chrome.
Or Chrome. I use a couple different ones, but
Okay, so once you've created an account, switch to a white sticky so that I know. There's always one person who has the verification email not show up. It happens every time. I don't know why. How's it going?
It's okay. It just I have to do so many steps just to get into my email, so I probably should just use a different.
Oh,
So,
right.
let me just-
Anyone having some problems?
Yeah, I currently have an unsupported browser issue
What
on
do you do?
here. Update.
Chrome or
Did you do
I know, I don't have Chrome on this.
Oh,
yeah.
On this.
Yeah.
I'll just watch.
Yeah, you're good. Still working through it?
You got to send your message on your.
I did.
Or-
Oh, we're back, yeah.
Oh yeah, you got this.
Yeah.
I'm done.
You're done. Okay, there's a few people not quite done yet. I have not forgotten about you, but I'm going to move on to the next thing. I will come back and make sure you are not left behind. Okay, for those of you that are in your account right now, duplicate this capsule. So this is again why it's nice to follow along with these slides. Because you can click on the otherwise terrible bit.ly link. So put up your yellow sticky again. Okay. Ignore that it says Duke. Actually, don't ignore it. UC. There's lots of UCs, you know. You probably know that. You're the special UC, right? Best UCs. Okay. So, oh, right. We have a new view. So all my screenshots are out of date. We recently integrated with Jupyter Lab. So Jupyter Lab is a way of creating those Jupyter notebooks I mentioned earlier. So we integrated with them so that people who are using that type of tool don't have to learn a new interface. So what that means is that this screenshot is now out of date. Sorry about that. So what you do is go to capsule, and go to duplicate. And you should see UC workshop example copy, and that'll be your sign that you've created a copy. If you get to this, switch to white, and I'm going to do a little circular checking in with people to see how they're doing. How they doing?
So I just have an account, but then I'm going back here. Is that right?
Yeah, exactly.
So she's showing us what we have to review some else research. This is how you do it in Photoshop.
Right, in corrosion, and so I guess you need the thing.
Sorry. I hope
That's
I'm not
okay.
making you.
Yeah, no.
Unsupported browser, no! What are you using, Brian?
Explorer.
Explorer. I thought we supported. Oh no, Edge is Explorer.
I guess I don't.
You don't
It's not
have.
that
You have
version.
Firefox there. Do you mind using Firefox? Sorry about that, guys. I bring back all this information to my team, and it helps for me to say, like, listen, 3 people in the room couldn't do these exercises because of the browser, and that helps, make my case that it's something we should worry about. What's that? 3? 4? How many people?
What?
What's your question?
Oh, have unsupported browsers.
Oh.
You guys are good? You're good? How are you doing?
I was
Okay, you're in there. That's good. Oh, we're not there yet. You're ahead of me. So, go back to the slide deck. Go up a little bit. Up a little more.
Yeah. I was kind of messing around with it. I was going to say actually to see like who else can I tell for really solutions.
Yeah, well, I have the link there if you just want to use them. I think
No, I heard this though.
this right here.
Yes, it's correct.
That's
Someone else is doing
okay, that's
That's
right.
what that was.
Yes,
I'm just saying like.
Okay, great. Now,
There's a fair.
okay, I think we're all good now.
So then.
All right. So this is sort of meant to be a skeleton of an example that you can refer to as we go through the next exercises. The sort of things that you would find in the code subdirectory or the data subdirectory to create a repository that is executable. So that's essentially what CodeOcean is. There's other examples of this as well. Binder is one example. And Wholetail is a new one that's coming out now too. So what these essentially are places to not only store all of your research materials in one place, but to have the relationship between them and the computational environment that you used, for example, all there configured. So other people don't have to do that themselves on their own computer. They can just come to it. They can reuse it. They can download it, run it locally if they want to make it more than just possible, but actually easy to build upon someone else's work.
A question about, a quick question?
Yeah.
Does it also store your large images, things of that sort?
Yeah, yeah. So we don't have any limits to the size of data or code that we can support, but obviously how you would normally upload this, that might be a barrier. If you've got like massive data, to upload it this way might be time consuming. So if you have like a huge data set and you do want to use CodeOcean, I would recommend reaching out to somebody there or me beforehand, and we can find a way to do it that's...
How big is big though?
Well...
Like 1,000 lines is not big.
No. Yeah.
Like
Yeah.
10,000 lines.
Oh yeah. Well, I mean, code is no problem. It's just like really, really big data is sometimes the problem. But it's not a problem, it's just a time thing, right? And it's also for long computations. Like, you can, like, we have, you know, computing resources here for people to, like, run your code and to get your repository configured, right? Sometimes for some of those capsules, it's going to take hours, days, weeks to actually run it, depending on what kind of computation you've got going on, right? But that's okay. Because what this is currently focused on is that endpoint of sharing your research for reuse. So you do it, you configure it, you do it once, then you publish it, and other people will see these are verified results. Yeah.
How do you know who has made the changes?
Who has made the changes?
Yeah, how do you conform with guidelines as to who changed the data if a change is made?
Yeah, so if there's a few different things in that. So if you are the owner of a capsule and you're uploading things for publication right now, you're likely to do all the configuring yourself and then add your co-authors. And currently there isn't, we don't have version control in here yet, so it's not an appropriate place to actually develop that code. It's just an appropriate place to share it. So if you're making a change to a bit of code and then one of your colleagues makes a change, you can't actually see who did what, right? So you would want to use GitHub for that, or another version control system. Though we are integrating with Git and should have that rolled out in the next few months, in which case it would be every change would have not only when it happened and who did it, that would all be tracked in the project history. People could see, you know, who contributed what in the project itself. So that's a roadmap thing. Yep. Okay, we only have half an hour left, so let's try and get through some of the things. Okay, so that is our sort of exemplar example. Thank you.
Thank you.
Yeah, appreciate it. Always refer back to the slides and ask me if you have questions later, okay? Okay, so that was an example repository or capsule, as we call it, that I made you duplicate, but we're going to go through how to create a new one with the data that we collected, okay? So everyone put up your yellow sticky. We're going to go, and you know, I'm going to switch back to the old editor just because that's what all my screenshots are. You can use whichever one you want, but I think this is easier because of the screenshots, right? Okay. So first things, I like to leave this tab open just so I can refer back to it as we're going through the exercises. So I just opened up the dashboard in a new tab. And here I'm going to create a new compute capsule. Okay? You can use, if you want to do your own thing, like put up your own code and data and play around, feel free to. And you can use whatever language it is that you currently use. So we support all open source languages as well as Stata and MATLAB. And the list is always growing based on what licensing agreements we can get. What's that?
SAS.
Working on SAS. Yeah, totally. I've been telling them, I'm an epidemiologist by training, so it's like people use SAS in my discipline. We need SAS, but we've got to get the licensing agreement with them finalized first. Okay, so once you've created a new capsule, I created it in Python. If you want this to run by the end of the workshop, choose Python. Just because that's the example, not because it's easier or anything.
How do you hit new? Where do you get that?
Yeah, so if you go to the dashboard, here, click New Compute Capsule,
I see right there.
and then click on Python.
Right, sorry.
No, that's not it. I always have to do this part twice, because I always go through it too quickly. And then I have to
I think we did it.
Like, we could write that too.
use
So weird.
candies. So you can name it anything you like. And you'll see here it comes with just some example code and data so that you understand, what's going on. So you've got your code in the code subdirectory, you've got your data in the data subdirectory, and then you've got your results subdirectory over here. When you click run, it runs this, what's called a shell script or a master script. And it will do whatever this thing is telling it to do, which in this case is like, run this Python code with this data.
Use it right here. Yeah.
And then it makes the output. So in this case, it's the figure here, right? So that's just an example. It's not like anything scientific.
Using art.
But we have real data from our candy swap that we're going to put into our tabs. So everyone put up your. I didn't tell you to switch it. Oh, I didn't tell you to switch it because I didn't check in with everybody. Is everyone able to create this capsule? Switch to white if you are, or thumbs up like you did. It's also.
Yeah.
By the end of it, it's like no more stickies, please. But I swear it's easier for me to do it this way. Okay, everyone's good. So yellow sticky up. And the next thing we are going to do is move our code and our data into our code and data subpanes. Remember I said best practice is to separate data and code? So that's what we're going to do next. So everybody go to this GitHub repo. The address is github/aprilcs/candytrade. You'll see it in here as well. Once you've reached that GitHub, switch to white. Okay. All right, back to yellow. Everyone's on the same page, which is good. Now, download the repo. The Candy Trade Master. Shouldn't take too long. Once you've downloaded it, switch to white.
Did you just click on just the green?
Yeah, clone or download, and then click download zip. For some reason, mine is taking a really long time. Okay. Great, so switch it to white when you've got it downloaded. All right, we're all good. Now, we have to unzip this. So, in my computer, all I need to do is double click it. That's probably the case for most of you.
Yeah.
Once you, okay, I didn't make you put up your yellow sticky. Everyone put up your yellow sticky? When you've unzipped your file, switch it to white. Okay, we're good. All right. So we've got this blank, boring repository. We want to upload some files. So you can either actually, dragging and dropping is probably the best way for most people. So the first, actually, I know I did that too fast. Let's go back to this again. Okay, first we're going to upload the code, okay? So we're going to click on this little upload file here on the far left. This is one of the ways to get things in. You can also get them in directly from GitHub. So we're going to click upload file. And we're going to if you see here, we have 1, 2, oops, no, 2, 3 code files. candytrade.ipynb is a Jupyter notebook. Fig1 happiness of individuals.py and fig2.py. Those are all code files. We'll put those in there. Okay, so everyone put your pink stickies. It's usually pink. Your yellow stickies up. Then drag in your code files. And once you've successfully added your code files, switch your sticky to white. Okay. I'm going to come back to you. Okay. So for the data, similar thing. Click, put up your yellow sticky. I always forget to do that at the beginning of the exercise. And then you want to put in your data. So we're going to put in our completed protocol. We're going to put in our data.csv and a README file. For those of you that might not be having a good time with the drag and drop, you can also just choose the files this way. You click on that and then just pick them that way.
One data file.
There's only one data file.
Did we use the cloud again for these? Or no, I didn't.
The cloud, yes.
Missed, okay.
Yep.
We did the same.
So once you have data in your data subdirectory and code in your code subdirectory, switch to white.
If your data is on your code subdirectory, how do you move?
Oh, yeah, with great difficulty. Unfortunately, our drag and drop is not live yet. So you actually have to, say you have data in here, you would, if you want to delete something, for example, I'm going to delete this main.py because it's just the example. You click on actions and then you delete.
You have to delete and upload again.
And then upload it again into the right place. It's like the 70s.
What's this reproducibility best practices file?
Oh yeah. Oh, thank you for asking. The reproducibility best practices file. Let's upload it here.
In the data?
It doesn't really matter where it goes, to be honest. Oh, right. You have to drag and drop that one. Sorry, because it's a folder. It is just my favorite guidance, reproducibility guidance documents. So there's 3 guidance documents in there. It's just for your own resources. If you wanted to read a little bit more about reproducibility, these are the best examples. So I just had them in there for people that want to read those. So there's good enough practices in scientific computing. This is excellent. It's very practical. Focuses on what someone who is not a software developer can do to improve their coding, because that's most of us, right? Okay, so we don't have a ton of time left. Is there anyone that is not been able to upload the code and the data into their subdirectory? Raise your hand. Okay. I've lost my cursor. Here we go. Okay. So, once you've created a repository and you have all your files in there, you want someone who finds that repository to understand what is in it, how those files relate to one another, and how they can get started with reusing your repository for their own purposes. So that requires documentation. Literate programming we mentioned briefly, and I'll talk about tomorrow in some detail. It's just a way of making your analysis more human readable. You should be sure to document every element or variable in your data and every element or variable in any model that you build, so that other people understand, what that variable name that you chose actually means. What are the units? What was measured? Are there natural thresholds? Things like that that can allow them to reuse that data or that model. And then create a README file. Thank you for coming. I have examples in here of guidance on how to create a good project level README file to accompany your repository, as well as how to create a data dictionary. But we obviously don't have time to do those things today. They're not exercises, but the slide deck is intended to be a reference for you guys to come back to if you want to. So you have, for example, some code that you've created, and we've uploaded some code onto our repository. There isn't any way in a published paper right now to directly express the dependencies of that research. So again, dependencies are all those files that are needed to reproduce the findings, the tables, the figures, as well as any libraries or packages that you used in the code. So what can we do? We can use a new technology called containers. Raise your hand if you've ever heard of Docker or the word container before. All right, so what a container is for our purposes is a way of taking your research analysis, packaging it up into a container, a little isolated sort of virtual box that allows you to move that analysis from one computer to another, from one environment to another, where it is independent of, for example, what hardware you're using, what software you're using, all these sorts of things that can really muck up someone's ability to get your analysis running on their machine. So container technology just makes your analyses portable and reusable. Software engineers use it all the time, but we're not software engineers, and we shouldn't be using software engineering tools because it takes too much time for us to learn, and we should be using our time in other ways. So all you need to know about containers is it helps to improve the portability and reproducibility of your work, and that it's what a lot of these online platforms that allow you to run code, that's what they're using in the back end. So Docker is a commonly used one, Binder is another example, and CodeOcean is an example that uses container technologies. And when we publish containers, it makes it easier for someone to get started with reusing your code. But in order to create a container, you need to specify what's called your computational environment, as well as document all of the packages or dependencies that you use in your analysis. And this allows you to configure a container and make your analysis portable. So again, this is a reference for you. We're not going to go through all the details now, but if you want to learn about how to document dependencies, there's some resources there about how to do it when you're using different types of languages or technologies. Okay, so the first thing that you have to do is specify the run environment for your analyses using container technology. So we're going to do that using CodeOcean, but you could use this. You could do this directly in Docker or in Binder if you chose to. So yellow stickies up. Thank you. Grab some food on the way out if you want to get in. Okay. So I did that really quickly. Put your yellow sticky up and then click on this ENV Environment tab. This is where you configure your run environment. You create a container based on, so you ran that analysis, say, on a local computer, for example. You used a particular version of the tools you were using. And those versions can sometimes be important for that analysis to actually work, right? So, for example, if I use Python 3 versus Python 2.7, my code might work in 3 but not 2.7. So for our purposes right now, we're going to use Python 3 with Anaconda and Miniconda 4.3. Okay, so once you've done that, switch to what? Sticky. It's in the Environment tab, for those of you that are. Okay, we look to be there. So next, we are going to install our packages. So packages are just little bits of code that people who are using code to run their research analyses might use. Anyone in the room use coding for their analyses? What language do you use? R, yeah. So for R, for example, ggplot2 is a commonly used one. So these are things that make it easy for you to just, add certain function to your code without rewriting it from scratch. These dependencies have versions, and those versions can affect whether your analyses will run or not. So you need to specify them. So in this particular case, we're going to specify them in this environment tab in CodeOcean. If you weren't using a container technology, you could use these requirements.txt files, which are essentially just a way of freezing your requirements into a readable document that you would just include in your repository. The instructions for how to do that are just right here. But what we're going to do is add through whatever installer we used. An installer is just where you got your packages from. We're going to add them here. For example, Jupyter. Type that in there. I told you time was going to be my greatest challenge. Jupyter, NUMPY. These are just examples of packages that I used in the code that I've used to analyze our data. What else is in there? Pandas. Pandas. The cutest of packages. So when I add just the package name and not the version number, it'll just default to whatever the latest available package is. But if you actually know what package you used, you can specify that here. So some of you, if you started your analyses on a local machine, say a year ago, you might actually be using not the latest package. So you would want to specify that here. And CodeOcean has all these packages archived, and will pull in the latest, or that version that you've specified. So once you have added your packages, switch to white. Everyone's already white. Oh no. Okay, raise your hand if you have not been able to do that. How about that? Okay. Okay. So you specify your packages and dependencies. So the next facet of reproducibility that we're going to do in 4 minutes. Remember how I said I talked too much at the beginning? Yeah, it's a problem for me. Okay. Is to automate as much of the analysis process as you can. So that generally means that you are telling a computer what to do. When you're doing that, you're also documenting what you did when you share that code. This is another example of doing something that actually makes your life easier by automating some of the process of things you do over and over again manually, and at the same time improving the reproducibility of your work. So one of the important things is to create a master script that runs your analyses from start to finish. So this allows people to know what order things are run in. If there's anything that you're doing manually to a bunch of different files, you can create one master script that can do it to a batch of files. And that will actually show, what was done, so people understand how to get to the same results as you did. The other thing to think about is whether or not your code and data is, your analyses are portable from one computer to another. And one way of doing that is to use what are called relative paths. So that just means instead of putting c.desktop/April/Clyburne-Sherin/data, you just have /data as your subdirectory. And when someone downloads your repository, your code that is has a path to /data will be able to find that folder within the repository without having to go in and change that path. Okay, so this just goes over some of those resources again. So I'm just going to create the master script really quickly so we can rerun this capsule that we've created and hopefully be able to see our results. So sorry for rushing through that part of it. So the master script can be any script. It can be this is a shell script, but it can be an R script. It can be any language that you want. So we'll just go to our example. Remember the example that I made you duplicate at the beginning? That has the correct master script to run this particular analysis already there. So we're just going to copy and paste it in here. And hopefully, this one. I say hopefully because the chances that things run the first time you try them, as you probably know, is unlikely. You guys are all very kind.
Did you just hit run?
Yep. After I put in you have to put in the shell script, but once you put in the shell script, it should. Oh, there we go. It worked. Okay. So we have an executed. Remember I talked about literate programming in Jupyter Notebooks? This is an executed Jupyter Notebook that we created. It's got our. Wait, is that us?
No.
That's not us, is it?
Way too many people.
Oh. For some reason, the right data, I didn't have the right data in there. Sorry. But anyways, you get the point of.
My name is in there.
Maybe I accidentally added everybody
Oh, my
together.
name's in there too.
Oh, yeah.
But there's not, unless I'm going insane, there's not this many people in the room.
Right. It just got mixed up with everybody else.
But as you can see, we are
We're
leaving
happier.
this room happier than we entered it. Huh? Not bad. So yeah, I apologize for having to rush through that last bit of the exercises. I do welcome you guys to take a look at the slide deck. It's designed to be a resource, and if you have questions, get in touch with me. That's like my job to answer these types of questions. Just very quickly, if you are going to publish a repository, there's a few ways you can do it. You can have your repository in GitHub. You can use Binder as a way of making a container. We talked about containers, making your analysis portable. Zenodo is a repository for data and code that allows you to mint a DOI for your GitHub repository. And then you can put that DOI to that repository in your paper. The other way is to get a DOI through CodeOcean itself. So sorry, I'm over time. If you're interested in learning more about how this works, you can ask me. But generally speaking, when you publish a repository in CodeOcean, we call a capsule. It has your data, your code, your metadata, and your computational environment all packaged together. You can get a DOI for that whole repository together, and then you can share that DOI in your publication. It's an example of what it was. Okay, actually, I don't like to go over time. So this has been lovely to meet with you guys today. I'm going to stick around if anyone has questions, but thanks for coming. Please give me feedback on what works for you and what didn't work for you, things that are unclear, things I spent too much time on at the beginning, which I did. Because every time I do this, I take the feedback and I really do change the workshop based on people's experiences. So I really appreciate it. Thank you.
Thank you.
You can eat your candy now.
One quick question. So
Yeah.
tomorrow, you mentioned a couple of things that you might do tomorrow, but can you kind of touch on what's different about tomorrow? I'm not sure if I can go, but just information.
Yeah, totally. So tomorrow is preparing your code and data for reproducible publication. So the computational reproducibility things that we did will happen tomorrow. So creating a master script, we just spend more time on them.
Okay.
And then we also actually create some documentation. We create a README file, we create a data dictionary, we choose a license, for example, we create some metadata. And the most important difference is people are invited to bring their own code and data. So if you have code and data and you're ready for publishing it, it could be quite useful for you. If you're not there yet, then maybe it's more information about something you're not ready for, in which case just reach out to me when you get there, right? So you're all welcome to come to both, and there is some overlap, but it's also quite different as well.
Okay,
Yeah.
thank you.
Yeah, thank you. Any other questions?
And April, can you confirm, I mean, right now, anybody could upload and you create a capsule for free.
Yes,
And then-
it's free for researchers, exactly.
Yeah, it's just, we don't collect any analytics or anything. If we had an enterprise license, then we can have that kind of information. But if you needed to publish code and data, this is a tool you could use right now.
Yeah, exactly. So academics, people with an academic email get, I think it's 10 automatic hours a month for free, like computer hours. Do you know what I mean?
Mm-hmm.
But the caveat on that is that we actually give researchers as many hours as they need to configure and publish their capsule. So we want people to be publishing. That's like helps us to get the word out that we exist. So don't look at the 10 hours and think that's actually a limit for you. That's more for reuse. If someone comes to your capsule after you've published it and they're playing around with it and they're like putting up their own data and playing around with it, then they might hit their quota on that. But if you're trying to publish, then there's no real limits to how much time we'll let researchers, to get their research out there.